Good afternoon. My name is Justin Long-Moton, and for this mini project number two, I will be demonstrating multiple linear regression methods as well as forecasting methods. Let us begin. For the multiple linear regression, I've decided to analyze a sample of 20 housing prices. The initial linear regression model, including the dependent variable, that being the home price, as well as 6 independent variables: the number of bedrooms, number of bathrooms, square footage, lot size, basement, whether or not they have one, and parking. These last two are the dummy variables. So from the multiple linear regression, the output, several determinations can be reached. The first being that 94.4% of the variance in the dependent variable is explained by the independent variables, and that's taken from the R squared value. So therefore, theoretically, the R squared value suggests that this model is valid. However, further analysis of the variables suggests otherwise, because when we actually begin to look at the variables, specifically turning our attention to the p-values, you can clearly notice that they are actually higher than alpha here being the 0.05. Essentially, this means that the variables are not significant, and if we're going strictly off of p-values, the only variable statistically significant is square footage. So therefore, for the sake of refining the model, I've decided to keep the three variables closest to alpha in order to see how these variables solely impact housing price. And now when we run this new model, where we remove the dummy models, that being the basement and garage, as well as the number of beds, independent variables, once these are removed, we come to the results that the remaining variables, bath, square footage, and lot size, are all less than or equal to alpha, therefore making them statistically significant. Therefore, it can be concluded that these variables are best suited for determining changes to the dependent variable. Okay, now shifting to the second part of the project, we'll be utilizing two different forecasting methods, specifically analyzing Bitcoin closing prices over a 2-year span, spanning from September 2017 to August 2019. So for the first method, we'll be utilizing a 4-month moving average. But before going into detail between the comparison between the 4-month moving average and the other method, exponential smoothing, it's important to note that, as indicated on the slide, the closing price line graph shows no discernible trends. Bitcoin seems to go up and down pretty sporadically with no trend established. So now when we compare the results, specifically looking at the MSC values between the 4-month moving average method as well as the exponential smoothing method, it's clear that the lesser is the 4-month moving average. So therefore, we can say that it gives the best forecast. However, given the volatility of Bitcoin over the last 2 years, neither method would really be suitable for accurately forecasting future closing prices because there's really no trend, no established pattern at all.